We have space mean speed. So space mean speed or harmonic mean speed, that's mu s, is the average speed of vehicles occupying a given length of road at an instant of time. So space mean speed mu s is equals to distance d over average time or t average. Then we have time mean speed. So this is the arithmetic mean of the speeds of vehicles passing at a point during a given interval of time. So that is mu sub t. So that's equals to the summation of all the space mean speed. That's mu summation of the mu s over n, the number of vehicle. Then we have flow rate and density. So flow rate is Q. It is the number of vehicles passing a point during a specified period of time, often referred to as volume when expressed in vehicles per hour. That's vehicles per hour, measured over an hour. Density is K. That is the number of vehicles per unit length. So Q is equals to K times the mu S, or density times the space mean speed. That is in vehicle per hour. Okay, then we have speed and density relation. This is the Green Shields model. Okay, this is the density versus the space mean speed model. Okay, then we have here the Q max. That's the maximum flow rate. So Q max is equals to 1/2 of K jam times 1/2 of mu F. And then the line, so the line is mu S, that's equals to mu F minus mu F over K jam times K. And K jam, so that is the jam density in vehicle per kilometer. So K jam is equals to 4 times the Q max over mu F. This is also in vehicle per kilometer. Okay, so mu S is space mean speed in kph. Mu T is time mean speed in kph. Mu F is the free flow speed in kph. Q is the flow rate in vehicle per hour, and K is the density in vehicles per kilometer. So K jam is the jam density in vehicles per kilometer. And then we have spacing of vehicles. S is equals to 1 over K. That is in meter per vehicle. Okay, we have an illustration here. So this is the S, spacing of vehicles from the center to center of the vehicle. And we have time headway. That's TH. That's 1 over Q. That's in seconds per vehicle. Then capacity of a single lane, that's Q cap, it's equals to mu S over S. Or that is also mu S over K. Okay. So, kana, multiply ni mo. And vehicle, that's in vehicle per hour. So we have also S is equals to mu S times T plus L, or equals to mu S times TH. So S is the average center to center spacing of the vehicles. TH is the time headway. Q cap is the capacity of a lane at a given speed. L is the average length of a vehicle. And T is the perception reaction time. Okay, then we have here average daily traffic, ADT. So that is the number of passing vehicles per year over 365. So mo ni siya ang igamit sa traffic, ang i-divide nga day, number of days in a year. It's 365 ang gamiton dire. So that's in vehicle per day. Then we have peak hour factor. Peak hour factor is the ratio of the traffic flow to the highest volume of traffic in 1 hour, based on the highest 5-minute volume of traffic. So PHV, that's peak hour factor, that's equals to the flow rate, which is Q, over the highest volume every time interval. Then we have accident rate. So accident rate is equals to the number of accidents over the number of entering vehicles. We have accident rate per million entering vehicles for an intersection. R rate is equals to N over ADT times T time times 365 times 1 million. And accident rate per 100 million vehicle miles of travel for a segment of a highway. So the rate is equals to N, number of accidents, over ADT, average daily traffic, times T, time, times 365 times length, L, times 100 million. So N, number of accidents, T, time of period of analysis in year, and L, length of segment in miles. Okay, okay, so we have example problems. So first example, the following data were taken on a 5 vehicles traveling a 1.5 kilometer portion of the NLEX. So you have vehicles 1 to 5. Then the time of travel, every vehicle, you have 1.2 minutes for vehicle 1, 1 minute for vehicle 2, 1.4 minutes for vehicle 3, 1.3 minutes for vehicle 4, 1.4 minutes for vehicle 5. So determine the space mean speed in kph and determine the time mean speed in kph. So for part 1, for the space mean speed, so that is equals to d over the average time. Okay, so the distance is 1.5 kilometers and the average time, uh, average of those 5 vehicles, the time. So 1.2 plus 1 plus 1.4 plus 1.3 plus 1.1 over 5. So this is 1.25 kilometer per minute times 60 minutes over 1 hour para mahimo siyang 75 kilometer per hour. Okay. Then part 2, you have the time mean speed, mu t is equals to summation of mu, that is the space mean speed, every vehicle over n, the number of vehicle. So you have 1.5 over 2 plus 1.5 over 1 plus 1.5 over 4 plus 1.5 over 3 plus 1.5 over 1.1 over 5. All over 5 for the number of vehicle. So it is 1.268 kilometer per minute. Okay, times 60 minutes over 1 hour. Okay, it is 76.08 kph. So next, another example. So from the following data of a freeway surveillance, there are 5 vehicles under observation, and the following distances are the distance each vehicle had traveled when observed every 2 seconds. So you have again vehicles 1 to 5 and the distances they traveled for 2 seconds. So determine the space mean speed in kph and determine the time mean speed in kph. So part 1 for the space mean speed, distance over time. So distance, average of the distance of the 5 vehicles, 2.4 plus 2 point, at 24.4 plus 25.8 plus 24.7 plus 26.9 plus 22.9 over 5 all over the time, which is 2 seconds. So mu s is 12.47 meters per second times 3,600 seconds over 1 hour times 1 kilometer over 1,000 meters. So it will be 44.89 kph. So part 2 for the time mean speed. So summation of mu over n. So summation of mu every mu s every vehicle Okay, so distance over time, you have 24.2 over 2 plus 25.8 over 2 plus 24.7 over 2 plus 26.9 over 2 plus 22.9 over 2 all over number of vehicle, which is 5. So you have 12.47 meters per second. So times 3,600 seconds over 1 hour times 1 kilometer over 1,000 meter. So that's 44.89 kph. Okay, so that's for this example. Next example. So 6 vehicles are observed in a 200-meter section of a highway. If the average time headway is 4 seconds, determine the density of flow in vehicle per kilometer. Then determine the center-to-center spacing of vehicles in meters. Determine the flow of traffic in vehicle per hour. And calculate the space mean speed in kph. Okay, so you have the 200-meter section of a highway. Then there are 6 vehicles in that section. Okay, so dili maklaro sa drawing. You have 6 vehicles and you'll have to solve an average distance of those vehicles. Okay. So part 1, the density of flow is K. So that's the number of vehicle over the distance. So 6 vehicles over 200 meters times 1,000 meter over 1 kilometer. So it's 30 vehicle per kilometer. And part 2, the center to center spacing is S is equals to 1 over K. So it's equals to 1 over 30 vehicle per kilometer times 1,000 meter over 1 kilometer. So you have 33.33 meter per vehicle. Part 3, the time headway is 1 over Q. So the Q is 1 over time headway, or TH. So equals 1 over 4 seconds per vehicle. So times 3,600 seconds over 1 hour. So you have 900 vehicle per hour. Then part 4, you have the formula Q is equals to K times mu S. So mu S is Q over K. So it's 900 vehicle per hour over 30 vehicle per kilometer. So you have 30 kph for Q. Okay, so next example. So the flow of traffic along North Reclamation is 1,800 vehicle per hour with a space mean speed of 90 kph. So the highest 5-minute volume is 214 vehicles. So determine the traffic density in vehicle per kilometer. Determine the spacing of vehicles in meters. Determine the peak hour factor PHF. So for part 1, K is, or from the formula Q is equals to K times mu S. So K is Q over mu S. You have 1,800 vehicle per hour over 90 kilometer per hour. So you have a K of 20 vehicle per kilometer, or that's the traffic density. Then spacing of the vehicle S is equals to 1 over K. You have 1 over 20 vehicle per kilometer times 1,000 meter over 1 kilometer. So that's 50 meter per vehicle. Then part 3, that is the you have a formula again that is PHF equals PHV over DHV. That is the peak hour factor. PHF equals PHV, that's the peak hour volume. And DHV is the design hour volume. So you have a DHV of 214 vehicle per 5 minutes. So times 60 minutes over 1 hour, you have a DHB of 2,568 vehicle per hour. So the PHV is 1,800 over 2,568. So you have 0.701. Okay, the next another example. So a portion of the extension of SLEX is known to have a free flow speed of 60 kph and a capacity of 3,600 vehicle per hour. So if a given R 3,344 vehicles were counted at a specified point along the highway, compute the space mean speed of this vehicle. Okay, so you have again the illustration of the green shields model. Then the given, you have mu f 60 kph, q cap is 3,600 vehicle per hour, and q is 3,344 vehicle per hour. You have this formula from the green shields model. So this formula also came from kani. So gikan na siyan. That's mu s over k jump minus k equals mu f over k jump. So and then it will turn to this mu s is equals to mu f minus mu f over k jump times k. So we can use that formula later. So we have also q is equals to mu s times k. So we can get the k para i-substitute dire. So q over mu s is 3,344 over the mu s, space mean speed. And the q max, that is also equal to q cap. So, and then 1/2, that is 1/2 of k jump times 1/2 of mu f. Okay. So equal na sila kay wala may gingon ani nga daghan siya og lane. Okay, so assume that this is only one lane. So the k jam is, you have also another formula. You have this before sa atong upper na part. 4 times q max over mu f. So that's 4 times 3,600 over 60. So you have 240 vehicle per kilometer. Okay, then we can go back to this formula. I-substitute na ang mga values. So mu s is 60 from here, mu f minus 60 over the k jump here is 240 times the k, kani 3,344 over mu s. Then you can use your calcu, you can shift solve to solve for mu s, or you can simplify first. Okay, then you can get that mu s is 38 kph and 22 kph. Okay. Another samples. So the number of accidents in 6 years recorded in a certain section of a highway is 2,456. If the accident rate is 1,420 per million entering vehicles, what is the average daily traffic? So you have the rate equals n over ADT times time times 1 million for this problem. And then we are looking for the average daily traffic. So ADT is equals to n over r times t plus 1 million. So that's equals to 2,456 vehicles over 1,420, that's the rate, times the time is 6 years, multiply that to 365 days for 1 year, times 1 million. So you have the ADT of 789.76 vehicle per day. Another, so it is observed that 50 traffic crashes occurred on a 20-mile long section of Route 120 in 1 year. If the average daily traffic on the section was 5,500 vehicles, determine the rate of fatal crashes per 100 million vehicles miles if 6% of the crashes involve fatalities. So the rate is equals to n over ADT times t times L times 100 million miles. So that's equals to 50 times the 6% of this traffic crashes is the fatalities. So 50 times 0.06 vehicles over 5,500 vehicles per day. Then multiply that for the time is 1 year and multiply to 3,600 at 365 days for 1 year times 20 months times 100 million miles. So the rate is 7.478 2. And then another example. So compute the severity ratio for the given data below. So you have a data from year 2010 to 2014, property damage for each year, injury for each year, and fatal or fatalities for each year. So the severity ratio, that is equals to the summation of injury plus the summation of fatal over the summation of property damage plus summation of injury plus summation of fatal. Okay, so that more man ay severe ka ng injury o fatalities. So it doesn't include the property damage, so that's the severity ratio. So sum up the property damage. So it's 917. Summation of injury 324. Summation of fatalities 24. So the severity ratio 324 plus 24 over 917 plus 324 plus 24. So your severity ratio is 0.275. Okay. So next. So we have here queue. So queuing is the study of traffic behavior near a certain section where demand exceeds available capacity. In transportation engineering, queuing can occur at red lights, stop signs, bottlenecks, or any design-based or traffic-based flow constriction. Okay, so when not dealt with properly, queues can result in severe network congestion or gridlock conditions. So therefore, making them something important to be studied and understood by engineers. So, okay, so we have mga formulas again. Okay, so traffic intensity. So we have I is equals to QA over QS. Okay, where you have QA is the arrival rate, QS is service rate, oversaturated queue. So it happens, so oversaturated atong queue when the arrival rate is greater than the service rate. Okay, for a while. Okay, so again, so your queue is oversaturated when the arrival rate is greater than the service rate. Siyempre, for example, you have a toll booth. So, naman na siya service rate kintahay ang ma-accommodate ra niya nga sakyanan is nanay certain time kung maka-accommodate siya 6 vehicles per minute na kintahay. Yeah. Mas daghan pa ang mga nag-arrive na vehicle. So mag-congest dito sila while waiting for their time. So ma-oversaturated ang queue. Undersaturated when your arrival rate is less than the service rate. Then saturated queue when arrival rate is equals to service rate. Okay, then we have Little's formula. The average queue size measured in vehicles equals the arrival rate. So vehicles per unit time multiplied by the average waiting time. So boost delay time in queues plus service time. in units of time. So that's ln equals the QA times TAB. Then average waiting time. So that's that includes service time. So waiting time TW is equals to QA over QS times QS minus the QA. Then average total delay, it includes service time. So total delay time PD is equals to 1 over QS minus QA. Okay. So we have examples here. So wait, wrong side din. This is TW. Okay, I will just edit that. So vehicles, examples na ta. So vehicles arrived at the entrance of San Juanico Bridge in Tacloban at a rate of 180 vehicle per hour. Vehicles must stop at the toll gate where vehicles will pay a toll fee upon entering the bridge. It would take 15 seconds per vehicle for the attendant to issue a ticket, to issue a trip ticket. So compute the traffic intensity at the bridge. So traffic intensity is katong I, which is QA over QS. So the QA, arrival rate, okay, so arrival rate is 180 vehicle per hour. QS service rate, so the toll booth can serve one vehicle in 15 seconds. So para mahimo siyang per hour, so 3,600 seconds over 1 hour, you have 240 vehicle per 1 hour. That's the service rate. Okay. So the intensity, traffic intensity, QA over QS, 180 over 240. So the intensity is just 0.75. Okay. So the service rate is greater, mas paspas ang service rate compared to the arrival of the vehicle. Then we have another. So an off-ramp traffic must stop at a single toll booth at the entrance of highway. The arrival rate at the toll booth is 80 vehicle per hour. If the service rate is 86 vehicles per hour, determine the number of vehicles waiting to be served. So, we need to have the QA and the QS. So, arrival rate is 80. Arrival rate is 80 vehicle per hour. Service rate is 86 vehicle per hour. Then we need the waiting time or the waiting time, average waiting time. So that is QA over QS times QS minus QA. So that's 80 over 86 times 86 minus 80. So average waiting time is 0.155 hour. So the average queue size, so that's QA times the TW. So that's 80 times 0.155. So you have 12.4 vehicle, say round up to 13 vehicle. Okay, so another. Okay. So this is an example of a board question. So a ramp meter operates during the morning peak period. Ramp meter cycles vary with time as shown in the table below. The metering scheme allows one vehicle per cycle to pass the signal. The table below gives the number of vehicles demanding service on the ramp during particular time intervals. The cumulative demand for the ramp for the morning peak and the ramp meter cycle for each interval. What are the service rates for meter cycle 12, 10, and 6? So you have given time period in that's every 15 minutes. So that's 6:30 to 6:45 a.m., 6:45 to 7 a.m., 7 to 7:15 a.m., 7:15 to 7:30 a.m., 7:30 to 7:45, 7:45 to 8 a.m. And then the volume in those 15-minute volume, so you have 75, 100, 125, 110, 80, and 65. Cumulative volume, so cumulative volume, so you have 75. So first, and then nadugang og 100 for the next 15 minutes. So nadugangan siya, you have 175. Then nadugangan og 125. So cumulative man is here. So you have 300. Then nadugangan og 110, you have 410. Nadugangan og 80, 490. Nadugangan og 65, you have 500. 50. Okay. Ito ba? Let me check. Okay, so marag set na siya. So it's supposed to be 555. Okay. Or maybe ang 65 ang nasayop sa given. Okay. Then you have meter cycle in seconds per vehicle. So 6, 10, 12. Service rate. So for the meter cycle of 12, so you have, if you could serve one vehicle for 12 seconds in the 15 minutes, so you times 60 seconds for 1 minute. So you can serve 75 vehicle per 15 minutes. Data nga yatag. Nira yung ipangayo. So the service rate for 10 minutes, if you can serve one vehicle for 10 seconds, 10 seconds. So multiply that in the 15 minutes service rate. So 60 seconds times 1 minute, so 90 vehicle per 15 minutes. And service rate for 6 seconds, if you can serve one vehicle per 6 seconds. So in 15 minutes, times 60 seconds per 1 minute, so you can serve 150 vehicle per 15 minutes. So mura na ang ipangutana sa problem. So next. Another. Okay. The Northern Luzon Expressway and LEX is designed to have a roadway capacity. It's designed to have a roadway capacity of 120 vehicles per minute. But due to the resurfacing of the portion of the expressway, the road capacity was reduced to 60 vehicles per minute. So the traffic arrivals are 80 vehicles per minute. The traffic then resumes 30 minutes. So compute the maximum queues in vehicles, compute the maximum length of queues. If the average length of one car is 4.5 meters, how many minutes will the queues dissipates, and determine the total delay in vehicle minute. Okay. So, i-graph na siya. Are, you have the arrival rate of 80 vehicle per minute nga graph. So, that's 80 vehicle per minute. Imuhang i-graph. So, constant siya. Then, so, dire, this is the departure rate, or that is katong service rate. So, for the first 30 minutes, normally, the capacity is 120 vehicle per minute. But then, you reduce siya into 60 vehicle per minute. So, you plot a time from 0 to 30. Kay the traffic after 30 minutes pa siya ni-resume katong normal traffic. So, you have the plot here of 60 vehicle per minute. So then after 60 minutes, nag-resume na siya sa 120 vehicle per minute. So until magtagbo na siya. So kaning shaded part, this is the part when the arrival rate nag-exceed siya so good. Ang arrival rate nag-exceed sa departure rate. So this is the part nga na ay queue or queuing. Okay. So ang part ani kay arrival man nga rates, and then sa ubos kay departure or the service rate. Okay, so mas daghan ang arrival rate kaysa departure rate. Then you have here the maximum queue in this graph. Diri nga part. Okay. So for part 1, you have the maximum queue of vehicle. So that's the arrival minus the departure. So the maximum queue is 80 times the time minus 60 times the time. That's 80 times, that is in the 30 minutes, kana ang maximum queue. So times 30 minus 60 times 30. So that's 600 vehicle. Then part 2, the maximum queue length. So the 600 vehicle times the 4.5 meter of one car. Okay, so the queue length is 2,700 meters. Then for part 3, so how many minutes will the queue dissipates? So Q is the arrival minus the departure. So you have here, putol ba? Okay. So Q, kung mag-zero na ang Q, so that's when the Q is 0, nag-dissipate na ang or nag-dissipate na ang Q when mag-zero na, or I mean dili mag-zero, magtagbo sila. Ani, tagbo na ang arrival o ang departure. Kaya at this point, mas mudaghan na ang departure compared sa arrival. Okay. So you have, so at what time ani? So 80 T, that's the arrival, minus the departure. Ani. So this gisolve ni siya nga departure rate, this one. So this departure rate dire, ang 30 minutes is 60 times 30, so you have 180. Plus the departure rate kaning 120, so that is 120 times the time minus 30. Since we don't know pa man the time ana, minus the 30 minutes. So
you have 180 plus 120 plus 120 times t minus 30. Okay, so you have this 1,800 plus 120 times the time minus 30. So the time is 45 minutes. So that's when the queue dissipates. So after 45 minutes. So that's the graph. So good na siya dire. Adtong nagsugod tong gi-reduce to 60 minutes, 60 vehicle per minute ang departure. So the delay is 1/2 times the number of vehicles, 600 times 30 minutes plus 1/2 times 600 times, we already know the time dire, so 45 minus 30. So you have 13,500 vehicle minute. Okay. Okay, so i-review lang na siya later. I will upload this material. So next, mahuman na tahapit. So another problem. So morning peak traffic upstream of a toll booth is given below. The toll plaza consists of 3 booths, each of which can handle an average of 1 vehicle every 6 seconds. So you have the time period from 7 to 8 in 10 minutes. So 7 to 7:10, 7:10 to 7:20, 7:20 to 7:30, 7:30 to 7:40, 7:40 to 7:50, 7:50 to 8. And the volume, 10-minute volume. Okay, so you have 200, 400, 500, 250, 200, and 150. Then you have the cumulative volume, so 200, then plus this from 710 to 720, so 400, so 600. Then 500, so you add that 1,100 na. Then plus 250, so 1,350. Then plus 200, so 1,550 plus 150, so 1,700. Okay, so determine the service rate of one toll booth every 10 minutes and determine the maximum queue and determine the total delay. So for part 1, the service rate of one toll booth is 1 vehicle per 6 seconds. So for each can handle an average of 1 vehicle every 6 seconds. So 60 seconds over 1 minute. So 10 vehicle per minute ang ma-service sa one toll booth. So multiply that, so 10 vehicle per minute times, multiply that to 10 minutes. So that's for every 10 minutes man. So you can have a service rate of 100 vehicle. That's for one toll booth every 10 minutes. So since Tulumane, there are 3 booths. So ang answer dito sa question, one toll booth, 100 vehicle. So if it's going to ask for the whole, the 3 toll booths, so it times na mo 3. So the 3 toll booths can accommodate 300 vehicle for 10 minutes. Okay, so let's proceed to part 2. So the maximum queue. Okay, so pwede na to i-graph. Okay, so that's from the previous table, meaning 10-minute volume and the cumulative volume. Then the departure. Okay, so the departure, di ba, it can accommodate 300 vehicle tanan. Kailangan man na to for the cumulative departure. 300 vehicle per 10 minute. So for the first 10 minutes, 7 to 7:10, 100 ay 200 naman ang volume. So you have the cumulative volume of 200. Then the cumulative departure, syempre at 200, so 200 po ang ma-servicean. So maka-depart ang 200 since 300 man ang iyahang ma-accommodate. So then every 10 minutes, you can add 500. I mean 300. So 200 plus 300, you have 500. Okay, so ma-accommodate na niya. Plus 300, so 800. Plus 300, 1,100. Plus 300, 1,400. Plus 300, 1,700. So the length of queue is i-minus nimo ning cumulative volume and cumulative departure. So this is arrival minus departure. So for the first 10 minutes, 0 ang queue. For the next 7:10 to 7:20, 600 minus 500, the queue is 100 vehicle. Then 7:20 to 7:30, 1,100 minus 800, you have 300 vehicle. This 7:30 to 7:40, 1,350 minus 1,100, 250. 1,550 minus 1,400, 150. 1,700 minus 1,700, so 0 na ang Q. So from this graph, makita na to nga ang maximum Q is at 7:20 to 7:30 where there are 300 vehicle. Okay, so pwede yan mo. Maximum Q is 1,100 minus 800, so 300 vehicle. So, let me see. Kung i-graph nimo ang arrival and the departure. Okay. So, kaning shaded na part, so that's the Q part. Okay. So, the delay, so you have the 10 over 2, that's the 10 minutes na period sa time over 2. Then you have 0 plus E times 2 ng every length of queue. So 2 times the 100, 300, 250, and 150. Then 0 po lang last. So you have 8,000 vehicle minute. Then you can times 1 hour over 60 minutes para mahimo siyang 1,300, 133.33 vehicle hour. So vehicle hour. Okay, so kaya po dog in vehicle minutes since wala man po siya gi-specify. But it's 133.30 in vehicle hour. Okay, another. So, okay, this is the last example. So during Christmas vacation, ramp meters along the expressway are open during the evening peak period from 5 p.m. to 6 p.m. The metering system of the SCTEX allows vehicles per cycles to pass the signal so that, for instance, a 6-second cycle corresponds to a service rate of one vehicle every 3 seconds, or 1,200 vehicles per 1 hour. The cumulative volume and meter cycles in each 10-minute period is recorded as follows. So you have the time period from 5 to 6 p.m. And then that's every 10-minute interval. And you have the 10-minute volume. So you have 150, 120, 150, 140, 160, 170. So the cumulative volume for the first 10 minutes, 150, So you add the 120, 270, you add 150 to 40 for the next 10 minutes, plus 140, 560, plus 160, 720, plus 170, 890. Then the meter cycle second, we have 6, 12, 10, then 6, and then 6. So determine the maximum length of queue and determine the total delay. So you have here the service rate per 10 minute. So that's at 5 to 5:10 until at 5:50 to 6 p.m. Okay, so the service rate. Okay, so one vehicle. So that's metering system allows vehicle to pass. Okay. So, i-divide siya og 2, the meter cycle. So, you can have one vehicle over 3 seconds. So, times 60 seconds over 1 minute and times 10 minutes. You have 200 vehicle, then one vehicle for 6 seconds. So, times 60 seconds over 1 minute times 10. So, you have 100 vehicle. Okay, and so on. So, you have 120, 120, 200, and 200. Okay, then for the service rate, i-expand lang ang table. So you have the service rate 100, 100, 120, 120, 200, 200. The cumulative departure from the cumulative volume 150. Then you will add the service rate. Okay, so the service rate per lahi man ang meter cycle nila. So you have 150 plus 100, so 250 plus 120, you have 370 plus 120, 490 plus 200, 690 plus 200, 890. So the length of Q is the cumulative volume minus the cumulative departure. So 0, 270 minus 250, 20, 240 minus 350, at 370, it's 50, and then 560 minus 490, 70, 720 minus 690, 30, and 890 minus 890, so 0. And you can graph the arrival minus the departure. Okay, so arrival minus the departure. So from this graph or from this table, you can, so that's the 70, the maximum queue at the 7:40 p.m. Kanang 7:42. The na siya abot from 7:30 to 5:30 to 5:40. So pagka 5:40 mo to ang nagkaabot na jud tong maximum nga queue. So the maximum queue is 70 vehicle. So the delay, again, this is for 10 minutes divided by 2. Then so 0 plus 2 times those length of queue. So 20 plus 50 plus 70 plus 30 plus 0. So the delay is 170 vehicle minute. Okay, so that's the last example. Okay. So that's usually divide to ang time and times 2 ang vehicle because mostly it's a 2-lane. So it's because of a 2-lane road. So that's all for our example. Okay, so it's 7:50. So next week we are still going to discuss na pa hatag ng mga notes. Okay. And then next week, so that's the last week of November, mag-quiz na punta sa highway. That will be our quiz 2F and that is also our last quiz. Okay, by the second week of December, that's already the finals. Okay, so that's for the last week of November atong quiz. And for this topic, transportation traffic engineering, I will allow you to write these formulas. Any formulas diri nga topic. Okay, so pwede mo magsuwat aning formulas diri for the quiz. Kanya lang nga topic I will allow. Okay. So that's for our quiz on the last week of November. Okay, so before we end our meeting, so please turn on your camera.